Hello. I'm going to work the problem that you solved in class in case there were any questions. So in this problem we have a concrete dam that has a specific gravity of 2.78, and we have the dam that retains the water and has a depth of 9 meters. And it gives me the specific weight of this water. The first thing is to determine the average hydrostatic pressure on the wall of the dam, then determine the hydrostatic force per meter of length, and then calculate the moment of the resultant force about point A in order to determine if the dam is safe from collapsing. And instead of collapsing, I should have used the word tilts, because this goes back to some of the concepts from statics. However, what you need to remember is that you have a weight here of the dam, and then you have a hydrostatic force. And whenever you calculate the moment about point A, these two forces have counteracting moments. So if we do the sum of the moments about point A and assume counterclockwise to be positive, what we have is that the dam would not collapse under one of two conditions. Number one, if the sum of the moments about that point equals 0, and of course that would be without any safety factor. And then the next one would be if the dam generates a larger moment than the water. So it counteracts that moment produced by the water. You will understand that better as we work the problem. So let's work the problem. So let's look at the dam first and calculate what would be the weight of the dam. And the weight of the dam would be the specific weight times the volume, and the volume would be the area times the length. So the area of the dam would be 1/2 of the base, which is 3 meters, times the height, 9 meters. So we have an area of 13.5 meters squared. The specific weight of specific gravity equals the specific weight of the material divided by the specific weight of water at 4 degrees Celsius. That's really important, because when I calculate the specific weight of the concrete, what I have is 2.78 times 9,810 newtons per cubic meter, which is the specific weight of water at 4 degrees Celsius. So the specific weight of concrete is going to be equal to 7.8, so 27,000, and it would be newtons per cubic meter. So when I calculate the weight of the concrete, what I have is 13.5 square meters, writing the units is important, times 27,201.8 newtons per cubic meter. Okay, so this would be equal to 69.3, and this is newtons per meter of length. Okay, so I can use kilonewtons because it's easier to deal with that. 368 kilonewtons per meter of length. If I use 1 meter, then the weight would be 368 kilonewtons. So let's assume that everything is 1 meter of length. Okay, so now I have the weight, and I know that this weight is going to be located at the centroid. So it would be located at a distance of 2 meters and 1 meter from the edge, and then 2 meters from point A, which is where I want to do the moment. Okay, so then I want to calculate now the resultant force, hydrostatic force, and for that I need to calculate the average pressure, P, which would be the specific weight of water times that depth to the centroid. Okay, so this would be the gamma, which is given, which is 9790 newtons per cubic meters, and the centroid would be 4.5. So this here would be 55. Okay, or if we use kilonewtons, here 44.1 kilonewtons per square meter. Now this is the pressure, but not the force, and so the force would be that pressure multiplied by the cross-sectional area for, so imagine that this is cross-sectional area, and we'll assume 1 meter. Okay, so it would be 44.1 kilonewtons per square meter times the area, which would be 9 meters times 1 meter. I'm sorry for the line that shows there. So the average, or the resultant force, would be 396.9 kilonewtons. Okay, so this would be, so the weight here, I have 368 for the weight of the dam, and for the resultant force, which is that. This is the resultant force, and this is the resultant force. So now I'm going to do the sum of the moments about point A, and this is now statics, like sum of the moments about point A, and I'm going to assume positive counterclockwise. So when I look at the resultant force, it generates a clockwise moment. And if you need to stop this video and look at that, feel free to do so. So minus 397 pretty much kilonewtons, and the distance from point A, and this is the weight, 390, oh, I'm sorry, I got it backwards. Let me erase this. So let me start with the resultant force. So that's 3.96.9 times, and remember that the location of this resultant force would be here 2/3 of 9 and 1/3 of 9, which is 3 meters. So this is kilonewtons, this is meters, and this produces a negative moment because it's clockwise. And then I have the other force, which is the weight, 368 kilonewtons, and then the distance, the perpendicular distance from that would be 2 meters. And this produces a clockwise, counterclockwise, so it's positive. So here, the resultant moment is negative 454.78 kilonewton meter, or 454.78 kilonewtons meter, and it's in this direction. So the moment from the water induced by the hydrostatic force of the water is larger than the moment that counteracts that moment by the concrete dam. So the answer is no, it's not safe. Thank you.